Just click and greetings to all my dear students. Well, for today, just like the last time, I would like to spend yet another session for the review of the recently concluded chapter of the data structures. The fact of the matter is this chapter is the biggest and the most important chapter of your curriculum, and then I guess it's worth spending yet another session for the review of this particular chapter. It's one thing to understand the concept, but it's altogether another thing to be completely confident of the concept. So for today we'll be solving some questions which appear at the end of your textbook and which will definitely feel you confident with regard to the concept of this particular chapter. So I've listed some questions. The first two are the programs which are to convert the infix expression to the postfix, and then you have the evaluation of the postfix expression. So over the last few classes we have learned properly with regard to how to actually carry out the conversion. But in this class, we'll be learning how to write a program that will carry out the very process of the conversion of infix to postfix and then how to evaluate. So since you have already understood the technique of the conversion, writing a program and then understanding it should not be a big deal as such. So and then you have following three questions, which are very much a part of the textbook questions, and then I would like to solve these questions also. So from the examination point of view, the later three, are the important questions. So let's get started. The first question is, write a program that converts an infix expression to postfix expression. And then in order to save the time, I have cited the example of infix. So this will be the input, and then if I manage to run the program correctly without making any mistake, I should get the desired output of this particular postfix expression, right? So we'll start with the first question. So let's make some rooms for the first question. All right? Okay. So first things first, I need to have a tuple called operators. Okay, operators. And then in the tuple, I would like to write all the individual operators, including the braces, the open brace, and then you have the closing brace, right? So we'll prepare the operators first. Okay, and then you have minus, and then multiplication, and then you have the division, you have the exponent, and then you have the opening, and then finally you have the closing. Okay, this program is a little complicated, so we'll make sure that we do not make mistakes while we do the coding. Okay, so you have all these operators, which form the elements of the tuple of operators, and then we'll have a dictionary. I hope you remember the data type of dictionary in which we have a pair of key and value, right? So I don't need to explain much because you are pretty much familiar. So we'll have a dictionary by the name of priority. Remember, when we have to convert infix to postfix, we need to check whether an incoming or a new operator precedence level is more or less, greater or lower. Accordingly, we need to pop and then we need to push. So for that, I take the help of the dictionary called priority. Okay, and then it starts with the curly brace. So let's assign plus with a value of 1. So which means the plus will have the lowest priority value of 1. Okay, So let's continue further, and then minus will have 2, okay, the value of 2, and then followed by the multiplication will have 3, and then division will have 4, and then finally we'll have the exponent. Okay, so this symbol represents the exponentiation operator, and then we'll assign 5 to it. Okay, so make sure that you come up with a correct definition, right? So these are the keys, and then these are the corresponding values, right? So through this, I'll be able to figure out whether this incoming operator precedence value is higher or lower than the ones which reside in the stack. So how can I do it? I could do it with the help of the values which are assigned to the individual keys. So exponent will have the highest, and then a little lower you have the multiplication and division, and then followed by the minus and the plus. Hence the values increase from plus to exponentiation, right? Okay, now let's come up with the function definition. Normally, whenever we write a program, it has to be done through the usage of the function, right? So let's define a function by the name of infix to postfix, right? Or just make it a little friendly to postfix. This is the name of the function, and then the argument. The argument of the infix, will be received from the main part of the program to the function header. All right. So I'm just defining the function as of now, and then once we are done with the function, we'll shift our focus to the main part of the program. All right. We now need 2 important variables. Remember, you have 3 columns: the element scanned, and then you have the stack, and then finally you have the output. If you could remember correctly, the element scanned, X, which is the stack, and then Y is the expression. So we'll have the stack first. Stack equals an empty list. All right. So we have been implementing the data structures like the stack and the queue through the list, right? And then this is the expression, and then we'll have an empty string value assigned to output. So you have the stack in the middle, and then you have the output on the right side. As and when I do the program, you need to visualize the actual technique of the conversion of infix to postfix. All right. So let's move on further. So this exp will have the input expression of this x plus y. It's not minus, sorry. It's x plus y. It all starts from here. Okay. So if the value of exp is received as this particular expression, the first thing that I need to do is I need to scan the element one by one. Remember, I need to extract the individual character. If it's operand, we need to have it directly added to the output expression. Okay, so you could actually do it with a traversal technique. So for ch in the exp, right? So this is the for loop which will help us to access the individual element. So the part via which we access the individual symbol of the element could be done through for ch in exp. So the value of exp is this particular expression, right? So ch for the first loop will assume the value of the left parenthesis, and then it will go on and on, right? So first things first, we'll write the condition for the operands. Okay, that's the straightforward rule. If it's operand, directly we have to add it to the expression. Remember? So the expression, or the output, the final expression of y is represented by the output variable. So I have this condition: if ch is not found in exp. Okay, so the first if CH is not found in operators, right? So the first value, from the expression, if it's not in the operators, so these are the operators, right? So if it's not in the operators, which means, the element has to be the operands, okay? So as of now, you have the operands like X, Y, Z, X, Y, Z, and then you have the R. So if the value of CH is not in the operators, if it's not found in this, if it's not found in the operators, then the CH will be the operand. If it's operand, then if the condition is true, which means it's an operand. If it's an operand, then I add it to the output. Remember? Okay. So this is the shorthand assignment operator, right? And then I write here CH. So initially, the output is an empty string, remember? And then the CH, the first value of CH will be the left, the brace. If it were to be X, let's say if the value of CH is X, okay? X is not in operators. X is not found in this. If it's not found in this, then it's an operand. If it's an operand, then we add it to the output, which appears right on that table of the conversion of infix to postfix. Alright? So I hope you're clear with this. It's pretty simple and straight. Now the next step is, if the element scan is the left parenthesis, okay? If it's left parenthesis, then what we need to do? We need to push it onto the stack. Now remember one thing. Now before you try to understand this program, you should have a complete picture of the conversion technique. Otherwise, you will experience difficulty in between. So if the CH is equal to the left parenthesis, okay? If it's equal to left parenthesis, remember we need to have it pushed onto the stack, okay? So stack, and then in order to push, we use the method of append, right? And then I write here CH. So till now, all the operands will be directly added to the output, okay? And then, the left parenthesis will be pushed onto the stack, and the name of the stack is stack, and then we use this method of append, alright? Now the next step is, if the character, which is scanned is the right parenthesis, remember, if it's the right parenthesis, then we need to, pop all the earlier elements, okay? And then we need to have it added to the expression or the output, okay? So LF, now this is the next rule. LFCH is equal to, if it's the right parenthesis, okay? I need to run a loop. Right? And then I run the loop till the matching left parenthesis is encountered, alright? So for this, I'll use the while, and then I'll have this stack. I'll explain a little later. And if the stack of -1, if it's not equal to, right? If it's not equal to, okay, the left parenthesis, I need to keep the loop running. Now let's try to understand this. Now let's say I come across the right parenthesis, okay, right parenthesis, and then I need to keep the loop running as long as the value of stack is not false, okay? So if the stack is empty, then I should come out of the loop. If it's not empty, then this represents true. If it's not empty, it represents true. If it's empty, it represents false. So as long as the value of this is true, as long as the stack is not empty, I need to keep the loop running. Okay? At the same time, I make sure that the last element in the stack, remember the -1 points to the last element. minus 2, second last, minus 3, third last. Okay, so if you want to run the indexes, in a backward position, we use the negative index. If you want to run the index forward, then we use the positive number starting from 0. So this will help us to point to the last element of the stack. If the last element is not equal to, if it's not equal to this, then I need to keep the loop running. All right. So which means the moment I come across this, I should terminate the loop. All right. So now the last element, needs to be popped, and then it has to be added to the expression or the output. I hope you are able to be with me. So the moment you have this, okay, the moment I have the element as the right parenthesis, I need to pick up the last element in the last operator in the stack. I need to pop it and then add it to the output, right? So I'll have this statement, output, okay, and then plus equals, you have this, and then I need to pop from the stack, okay, stack POP like this. Now let's say you have the plus operator, okay, you have the plus operator and then you have the minus operator, plus operator, minus operator in the stack, and then just before the plus operator you have the left, the parenthesis. Now let's say the moment this condition is true, the moment you have the right parenthesis, okay, the stack of minus 1 is not equal to the left parenthesis. Okay, so in stack of minus 1 you have the negative sign, right? So the negative sign is not equal to the opening brace. So the condition becomes true. I'm telling you the one second. Let's say you have a situation like this. Okay, it's better if let's say I have the situation like this, all right? So the moment you come across this particular the operator or the right parenthesis, the stack of minus 1 will point to this. Now this is the content of the stack. So this is stack of minus 1, all right? So stack of minus 1 is not equal to the left parenthesis. So the condition becomes true. If the condition is true, from the stack I pop. Okay, so whenever I pop, the top element will be popped off the stack, and then this minus 1 will be added to the output. So the negative sign will be popped, and then it will be added to the output. And then go for the next one. Now once it's popped, this condition is true, stack of minus 1. Stack of minus 1 now points to the plus sign, all right? So again, it's not equal to the left parenthesis, all right? So again, this condition is true that the stack dot pop, this will be popped off, and then it will be added to the output. So in the output, you will have minus followed by the plus. This is exactly that is being replicated in the conversion technique using the table, right? And then now the stack of minus 1 will now point to this, all right? The later two have been popped already. So this is not equal to this, the condition becomes false. Okay, so when the condition becomes false, remember, I need to get rid of this. Okay, please recall the technique properly. I need to get rid of this. So once I come out of the loop, what I do up next is, once I come out of the loop, it needs to be here. Alright, so in order to get rid of this left parenthesis, I simply have POP. So this statement will help me to pop the left parenthesis. It should not be added to the output or the expression, right? So with this block of code, we have taken care of the situation during which the value of CH will be the right parenthesis. Okay. Now the final the rule is you have the its. Now it's all about comparing the precedence level. We are done with all the possibilities except for the CH to be an operator. If it's operator, now that's where the main focus should be. If it's an operator, I need to first check the last operator in the stack and then do the comparison of their precedence level or precedence value. If it's less or equal to, if it's less or equal to the last operator in the stack, I should have that popped and then have it added to the output. Okay, I assume that you are completely thorough with the technique. So I'm just cutting it short. Okay, so let's move on. Now let's go a little up. Okay, else, and then I run the loop, alright, while stack is not empty and as long as, and then again, you have the situation. Remember, let's say if I have something like this, alright, okay, let's say if I have something like this. Now let's say the operator that comes in is multiplication, right? If the last element in the stack is the opening parenthesis, which means there is no question of comparison. Remember, it directly sits after this. So we need to make sure that as long as the last character is not the left parenthesis, this is important. Okay, so the second condition will be the last element of the stack should not be equal to the left parenthesis. Okay, if it is this, then there is you don't have the question of comparison. The first condition will be true. Okay, what happens is from here on it reaches here, but there will be no comparison as such. All right. And then, I guess it has to be OR, right? Okay, okay, fine. And then, now the next step is if one of these conditions is true, right? So it cannot be added between. And then now I have to take the help of, just make this full screen. Okay, priority. Okay, we'll take the example, we'll take the help of the dictionary, right? And then if I write CH, now let's say if the operator, if the next value of CH is say plus sign, okay? So the priority of plus will give us the value of 1, as is the case in the dictionary. I hope you remember, right? So when I say priority of CH, if the value of CH is plus sign, if the new element that comes in is plus, priority of plus, will give us the value of 1. Okay? So likewise, if it's minus 2, multiplication 3, division 4, exponentiation 5. So, with this, we would actually do the comparison. Now the precedence level of the new, okay, or the incoming operator, if it's less, remember, if it's less than the last element in the stack, or if it's equal to, then we should pop the last element in the stack and then have it added to the output. Okay, so hence you will have this condition. If it's less than or equal to priority, again I take the help of this dictionary. And then you are talking about the last element in the stack, right? So it has to be stack minus 1. Okay? You have something like this. I hope you are clear with this. The comparison, if the comparison holds true, the popping, the adding, I need to ensure that the priority of CH, the precedence value of the incoming operator, if it's less than the one which is already residing in the stack, then I should pop and then add it, right? So if the condition is true, if it's if the stack is not empty, if the stack of minus 1 is not equal to this, okay, or that, so if the condition becomes true, then I come here, I do this output, right, and then plus equal, I need to pop, remember? And then for that, stack dot pop, right? So from the stack, if the condition is true, and then I, pop it, okay? And then I pop this and then have it added to the output, all right? So I need to keep doing this. So once I am finished with the popping and the addition of that onto the output, the new or the incoming the value of ch needs to stay in the stack. Okay, it has to stay in the stack. Sorry. So this will be like stack dot append, and then you have the ch. Okay, so that's where ch gets into the stack. All right. Okay, so I think I've made a mistake here. I'm sorry. So this has to be and, right? They all need to be true. Okay, so they all need to be true. So once I'm finished with this, and then I come further down. Okay, so now this will be the last combination. The last combination for the rules of conversion of infix to postfix. Now there could be some elements left in the stack. After applying all the rules, once I'm done with scanning of the original, the infix expression, there could be some elements left. So they all need to be popped and then added one by one. Remember? Okay. So for that, I wanted to run a loop. So let's have it here. Okay. It needs to be. Okay. It needs to be a separate from the for loop, right? So I come here and then I run this while stack. Okay, as long as the stack is not empty, as long as the stack is not empty, and then I have the statement output, right? Output, and then you have the plus equal to stack dot pop, right? This is pretty simple. Okay, did I get this right? I'm not sure about the indentation. Okay, it has to be right. So now with this, we have come to the end of the program. Now let's check whether it runs correctly. But before this, I need to have the main part of the program, right? So the main part of the program will be something like this. Say infix equals. So it has to be this particular expression, right? So this is the infix. All right. So I just have this enclosed in a pair of double quotes, and then let's print the postfix. Okay, the postfix expression is equal to, and then I need to have the return statement, right? Okay, I need to have the return statement. Okay, right here. Now the statement that needs to be returned is the output, all right? Okay, so finally, once I finish with all the loops, in this particular loop, I then need to return the output. So let's call the function right here. So the name of the function is infix to postfix, right? So you have this postfix. Okay, and then I send the argument, and the name of the argument is infix. All right. So I guess I'm done, and then I need to close the bracket. Now let's check whether the program runs correctly. So this infix value will be sent to the function definition of infix to postfix, right? And then this whole thing will be run, and then at the end, the output will be returned back to the function call. And then this is how the value of the output, will be printed. Okay, I'm not too sure about, the correct running of the program, but let's check. Let's see. Okay, there you go. I seem to get the correct output. Oops, what's happening? Oops. Oh, sorry. Okay. So let's compare the answer. So this should be the final answer. You have xy plus you have zy, multiplication, division, or minus, right? So if you try this manually, this is the correct answer, and then when I ran the program, I do get the postfix, the correct postfix value, alright? So I thought, maybe if I come across a problem, the error, as like I always say, it'll give us a nice opportunity unless I get real, stuck. So this is the program that will help us to convert the infix to postfix, right? So if I just briefly tell you once again, this expression will be received in exp, okay, and then you have the empty stack. So this is the list, and then this is the string in which we will get the final output, and then for ch in exp, the first value of ch will be, I'll do this real quick. The first value of ch is the opening brace, right? Opening brace. Ch not in operators. Ch not in operators. Let parenthesis is not in operators. It is an operator, so the condition is false. Okay? What about this? Ch is equal to left parenthesis. So the condition is true. It will be directly added to the stack. Okay? It will be directly added to the stack. And then you have the output, remember, on the right side. And then, once the condition is true, it skips the rest of the nested loop, and then again it goes for, it stops here, and then again it goes for the next value of ch. The next value of ch is, you have the x. X not in operators. The condition is true. It's not in operators. So the first condition will be true, which means, the x will be added to the output. See, you have the x added to the output or the expression. So just like how we, actually carried out the conversion, the similar things happen here. And then let's do it one more. And then you have the next value of ch will be plus sign. Ch not in operators, the condition is false. Okay, plus sign. Now the value of ch is plus sign. So the condition is false. What about this? This is also false. What about this? This is also false. And then check. Check, the condition is true, right? The stack is not empty. -1, the last element. The last element is not equal to, this. Okay, so the condition is false. If the condition is false, I hope you're able to understand me. The stack of -1, the last element in the stack is the left parenthesis. The left parenthesis is not equal to left parenthesis. The condition is false. If the condition is false, this statement will not be executed. If this statement doesn't get executed, that signals the end of the loop, and then it comes here, stack.append ch. The value of ch being plus, will be added to the stack. Okay, so the status of the stack will be like this, and then y. Now next is the y, right? So we'll do it till here. Y ch is not in operators. Y is not found in operators. It's true. Okay, so have it added to the output like this, and then you have this the right parenthesis. The first condition is not in operators, it's false. Okay, it is an operator, so it's false. What about this? This is false. Now this time this condition will be true. The right parenthesis is equal to this. And then check, the stack should not be empty. And then stack of -1 is not equal to the left parenthesis. So the stack of -1 means this. -1, -2, -3, it goes on and on, right? So the stack of -1, which is the plus sign, is not equal to the left parenthesis. So the condition is true. Stack is not empty, which means it's true. Stack of -1, which is +1, is not equal to left parenthesis. The condition becomes true. And then stack.pop. From here, pop this and then have it added to the output. So you will get something like this. Okay? And then remember, I need to remove this. So once you go back for the next loop, this condition will be true, but this stack of -1 is not equal to left parenthesis. Okay? Now it is true, right? The stack of -1, which is this, is not equal to this, means the condition becomes false because they are equal, right? So this condition will evaluate to false. This statement will not be executed, and then what do you have here? Stack.pop. Just pop this, and that's it. Do nothing because it has to disappear, right? So I won't, move on with the remaining the symbols or the elements. Since you are very familiar with the technique, just follow. With the rest of the elements, the program should not have any problem regarding the conversion of the infix to the postfix. Okay. So, this is, that important program. Now, the next up is, we'll just have this converted to the comment, right? Triple single quotes or triple double quotes are used to convert the multi-line into the comments, right? Now, another interesting, okay. Let's pull this up. Okay. Now another interesting question is, write a program that evaluates. Remember, evaluates means I need to come up with the answer. Alright? So this, having converted the infix to the postfix, the computer now generates the result. It's easier for the machine to deal with the postfix. So now let's write a program. Even though these two questions are not technically a part of your the textbook, I thought why not bring it into the session. So this will only strengthen the concepts that you have learned over the last few classes. So write a program that evaluates postfix expression. So we need to generate the value. So let's run the program. But before this, I think I need this. So I just copy and paste it. Okay, I need this. It'll save my time. Okay, so I need this. Now the next step is, let's again do it through the means of a function. So the name of the function this time will be def, and then you have the function name as evaluate, and then you have the expression which is to be evaluated. Alright? Now this time, the postfix, will be this particular input, right? So this will be the postfix, and then we would like to have this converted to a value. But remember, this, in order to make the program very simple, I have these elements in the form of integer. Okay? 12, 7, 3 are the integers, but these are the character or the string values. Okay? So now let's start with the evaluation. Okay? Let's start with the evaluation. Now again, I need to scan the individual element one by one. I need to scan this. Now remember the rules. If it's the operand, I need to push it onto the stack. Operands, push it onto the stack. If it's an operator, I need to pop the number of elements as per the nature of the operators, and then evaluate, and then the result needs to be pushed back onto the stack. Just need to remember this. Okay, so let's traverse CHN. Okay, for CHN EXP. Alright, so this is the postfix expression. Now the question is, if CH are not in operators. Okay, if this condition is true, if the value of CH, the first value of CH will be 12. 12 is not found in the operators. Okay, so I don't have anything to do with these two. So I'll just get rid of this. Okay, these are the only possible operators. So if the value of CH is not in operators, we need to have it pushed onto the stack. Remember? So before this, I'll have an empty list defined like this, right? So this is the name of the stack or the list. So if the condition is true, then I need to have it pushed, the element onto the stack. So how you do it? You do it with the help of append. All right. You have append and then you have the CH. So this is fairly simple. So if it's not found in operators, which means they are operands. Operands will be pushed onto a stack. And then now the next up is, let's say if CH is equal to, you have the plus sign. Okay? If the next element is a plus sign, then we need to pop. We need to pop how many, the elements? We need to pop 2 elements, right? So let's do it. Let's say T1 equals the stack dot pop. So this will pop the topmost element from the stack. Okay, and then let's pop another stack dot pop. All right, we have stack dot pop, and then I need to carry out the addition of the 2 and then have it pushed back to the stack. Okay, it's pretty simple, right? So I'll have stack dot append, and then I'll just write here T1 plus T2. I hope you're able to understand this. So if it's a plus sign, then I pop the topmost element, second top element, and then have it added mathematically, and then have it pushed back onto the stack. Now once you understand this, the rest of the statements are pretty simple. So I can just copy and paste it, but when you do it on the system, please do not copy and paste it, right? So okay, for the minus sign, and then you have the multiplication, the division, and then you have the exponentiation, right? So let's make changes one by one. Be careful. If it's equal to minus, since addition is commutative in nature, you have a plus b is equal to b plus a, it will not make any difference as such. But in minus, you need to be careful. T1 is the first one to be popped off, so it will stay, second, and then the next element will stay at first. So when you carry out the subtraction, the first one, the topmost element needs to be subtracted from the second topmost element, right? So it has to be T2 minus 1. It cannot be T1 minus T2. You will go wrong. So be careful. So if it's a minus sign, then this will be like T1 will be the first one to be popped on. Where is it? It's here. It should stay here, and then T2 should stay in the front, and then in between you have the minus sign, which means this cannot be T1 minus T2, rather it has to be T2 minus T1. So you need to be careful of this order, not for the plus or the multiplication, it will not make any difference, but for the subtraction, the division and the exponentiation, it makes world of difference. So please watch out. So the next up is, I need to make changes here. This plus will be changed to multiplication sign, and then you have T1 multiplied by T2, right? It's simple, right? And then you have the division. Be careful, it has to be T2 divided by T1. Okay, so we'll use this, no problem. So this has to be T1. So we'll just focus on the integer part, alright? And then finally, the exponentiation, we'll just change this to exponentiation operator, and then again it has to be T2, alright, and then this is the base, and then T1 has to be the exponent, right? Okay, and then finally, once we are done with the major chunk of the program, we need to finally, remember, we need to finally return the content of the stack. So it has to be like return stack, return the content of the stack. And the answer that you will get, will be in the form of list with just one element, and that element will be the result of the evaluation of the postfix expression, right? Now let us shift our focus to the main part of the program, okay? The main part of the program will be something like this. EXP expression is equal to, this is the expression, remember? Okay, so this has to be the input. It has to be here, alright? And then we'll call the function, we'll print, and then the result is, okay, and then let's call the function, the name of the function is evaluate. Remember? You evaluate, and then I sent the argument of EXP. EXP will be received by EXP on top, right? And then once this particular function is done with the execution, it will return the stack, okay, which will be printed with the help of the printing statements. So we'll just check whether we are able to get the right output or not. Okay, so we'll just run this. Press F5. Okay, there you go. We get the right answer as 15. Right? So roughly, if I try 12, 7, 3 minus. So 7 and 3, will be popped. Okay? 7 minus 3 will be 4. 4 will be pushed back to the stack. Okay? And then you have this division sign. Pop 12 and 4. 12 divided by 4 is 3. 3, will be pushed back to the stack. So you will have 3, 2, 1, 5. And then you have this plus sign. 5 plus 1 is 6. So I'm losing track of the numbers. So it'll be like 3, 2, 6. Okay? And then 6 and 2 will be multiplied. Right? 6 and 2 will be multiplied. 12 will be pushed back to the stack. And then at the bottom of the stack you have 3. Okay, and then finally, when you add 12 and 3, you will get the answer as 15. So fortunately, I managed to run the program without any error as such. So these are the two very important programs which will not only help us to convert the expression from infix to postfix, and not just know how to evaluate it, but we are now equipped with the programming knowledge of how to do the conversion and how to do the evaluation through the programming means. Now this is a short way to strengthen the concept or the knowledge, right?